So we are talking about measuring circles. How do we measure the circles? Yep, somebody raising hand.
It was by accident.
Okay, that's fine. Now, this is a circle. Looks like a circle somewhat. Yep. Now, when you say measuring circles, what do we measure? We measure. Yeah, go ahead, Michelle.
You can measure the area, the circumference, the angles, and the radians,
See?
and a lot other.
Okay.
Diameter as well.
Yep.
Yeah, and radius and chord.
Yeah. So let's go one by one. Now, when you say area of any shape is essentially the space taken by it on the surface. This circle needs bigger area. This circle needs smaller area. This tiny circle needs very little area, right? So if we relate that in layman's term, area is nothing but the space taken by any shape on the surface. Yeah. Hey everyone.
Hello.
So everyone, we just started the class, and in today's class we are going to talk about measuring circles. So different things that we need to learn about measurements of circle and its properties and different parts of circles. That's what we'll cover, and then if time permits, we'll look at one of the circle theorem also. Okay. So we started with what do we measure. So obviously I got multiple responses from you guys saying you measure area, you measure circumference or perimeter, you measure chord, you measure arc, you measure sectors, whatnot. Let's go through them one by one. First, let's understand what are the different things or the different properties or the name of the parts of the circle. If this is my circle, I have learned how to make a good circle, it seems. I'm drawing a decent circle. So, if this is a circle, what are the things we know about the circle? This is the center, and this is the line that we see, that is the circumference or the perimeter, whatever you call it. And every point on the perimeter is equidistant from the center. Every point on the perimeter is equidistant from the center, meaning if you pick any point here and measure the distance between this point and the center, that will be same as pick another point and that from the center. They will be the same. That's the first thing we know. And this distance is called nothing but the radius. Same way, if you have a circle, if you just break it into two equal parts, meaning a line that crosses the center and splits the circle into two equal parts, this line is called a diameter. And if you look at it carefully, the diameter is comprising of one part this way and other part this way, meaning one radius here, one radius here. So diameter is equals 2 times the radius. Yeah, up to this much is fine, right? Now there are certain formulas that we know. See my confidence. I'm able to rub the circle and I'm able to draw it properly. So that comes with practice. More you do, better you get. So here we just talked about what is area. Area is the space taken by this on the surface. If I have to draw, the maximum size of circle that I can draw is going to be this much, which has to be within the area of this board. I cannot go beyond this one, right? So the board has certain area and circle is using some part of the area. So that means if I have to draw a circle on the board, my area of the circle has to be less than this one. Otherwise, I'll not be able to draw. Now, how do you find the area? How do you find the area of a circle? Area of a circle is
Pi r squared.
pi r squared where pi is a constant. It's a gift from the ancient mathematicians who did all their calculation and found that pi equals 22 by 7. This is a fixed value. Now you can convert this fraction to decimal, which will become 3.1416 and still continues. So you can choose this or the decimal portion of it depending on what you are comfortable with. I have always remembered this as 22 by 7 because that cannot go wrong, and I always know how to convert a fraction to a decimal. So if I'm being forced to convert to decimal, I'll convert to decimal and then use it. But otherwise, I'll use 22 by 7. And r is nothing but the radius, means the distance in the center and any point on the perimeter. This is first formula. Now the perimeter, the circumference is nothing but the length. If you kind of cut it open and convert this to a wire, this is the length of the wire, basically. Yeah. Hi Sandri. So the perimeter of a circle is nothing but 2 times pi r. Again, pi remains the same. R is nothing but the radius. So the kids who are joining little late, we are just doing measurement of circle today. So we started with understanding what is a circle, how is what is the radius, what is the diameter, which you all know. I'm just doing a recap and then we will dive deeper into it. So we just looked at what is the area of a circle, that is pi r squared, and what is the perimeter of a circle, this is 2 pi r. Now let's add a little more fun to it. And see, you all can feel jealous about it. See how confidently I am drawing circle in a good way. Yeah. I didn't know that I can do so, okay, but I am able to. So that means I've done enough practice recently. Now, if I pick 2 points on the circle and I join them. Do you guys know what is this called? AB?
The chord.
The chord or chord, I don't know what is the right pronunciation for it.
Yeah.
I'll call it chord, but if you guys pronounce it differently, I don't mind. Yeah. So this is called chord, and if you look at the curvy part of it, that is called arc. The straight line AB. So let me differentiate it. Let me pick a point B here. So AB is called chord, and ADB. Basically, I'm trying to say that this is the curve part. This is called arc. Right? Like if you guys have played with bow and arrow, you would have seen those, where you stick the arrow. That's like an arc. Something which is like not a straight line. Something which is curvy in nature. Yep. That's called arc. So this is the arc of a circle. So basically, if you look at a chord AB, this splits this circle into 2 parts or 2 arcs. One is the bigger arc, one is the smaller arc. You can choose. So I said ADB. That means I wanted to say I'm picking the smaller one. If you pick a point C here and then you say ACB, then you're talking about the bigger arc. Yeah. Now, see my confidence again. So I pick 2 points, I join them, I call this AB, the straight line, as a chord, and this curve as an arc. Now, this is my center of the circle. If I join these 2 points with this one, do you know what this angle is called? Center angle. The angle that is made on the center by the chord is called center angle. Yeah. And if you look at these two points on the perimeter, basically, if you look at this line and this line, they are nothing but the radius, 2 radius, and they are kind of cutting a piece of the circle. If you imagine this is a pizza, This is one slice of the pizza, and this is called sector. This is called sector of a circle made by these 2 points. Yep. So radius everybody knew, diameter you all knew, what is perimeter, what is area, that we all knew. We are looking at some more properties. Basically, instead of looking at the entire circle, if I am looking at a piece of it, 2 points, I join them in a straight line, that is called chord. The curvy part is called arc, and these 2 points make certain angle on the center, that is called center angle. Yeah, Dikshita.
So the center, is it center angle or sector angle?
Center angle. Angle made on the center, that's what is called center angle.
Okay.
Yeah, Vasundhara. Vasundhara, you were saying something? No?
Didn't say anything.
Oh, okay. Alright. So these are the things that we know as a term. Now, let's play with it. So, if I say this is my circle, okay, and I pick 2 points on the perimeter A and B, and this is my center. Point A and B is making a center angle of, let's say, 60 degrees, and the radius is equal to, let's say, 5 centimeter. Now, if I ask you guys, find out the length of the arc AB, the smaller arc, who can try finding it out? Think. I mean, you don't have to try solving it. Think about it. I'm saying this is my circle, this is my radius, and I have picked 2 points on the perimeter A and B. I join these 2 points with the center, so this is making a center angle, 60 degree. If I have to find out the length of AB, the arc, who can find it out? Or how? At least tell me the approach if you can think of it. And you can, yeah, Vishal.
No, I said this 1 minute. I'm
Thinking? Okay. And you don't try solving it, okay? I'm not in a hurry to get an answer from any of you. I'm more interested in understanding what would be your approach. Yeah, Dikshita.
Are we gonna use the pi formula?
Pi formula? I don't know what that formula is. You'll have to explain that in layman's term. Yeah, Vivan.
I'm sorry, what's the radius again?
Radius is 5 centimeter.
5 centimeters.
So again, I'm repeating the question, okay? Like I always say, Tran, right? Trust, read, analyze, and then Nike. Just do it. T part is given. R, read. I'm reading the question again. Let me read one more time and then I'll come to you one. I have a circle and I have picked 2 points A and B on the perimeter, and when I join these 2 points with the center, which is making the center angle of 60 degrees, I'm asking how can I find out the length of this arc, and how, meaning I am just more interested in knowing the approach. Yeah, everyone, go ahead.
I'm sorry, so what I did to solve this is, so basically like I looked at a triangle and I saw like 60 degrees, and since there are like two other angles and all of them add up to 180, and 180 divided by 60 is 3, so all of them are 60 each, and since all of them are 60, like one angle, like one side length would be equal to all side length. So like the radius, so basically like the answer equals like 5 centimeters.
Okay, you started in the right direction, but somewhere you took a small diversion. I'll fix it. Don't worry. Yeah, Vishal, tell me.
I got one of these type of questions before. So I know the formula is basically the length is equal to the degree divided by 360 since the whole circle is 360 degrees, multiplied by pi r squared since that's the area. And then so I put 60 as a degree, so that would, and 360, so that's, I got 1/6. And the radius is pi, so I did pi squared, which is 25, and 25 times pi would be 25 pi. So, and I divided 25 pi by 6, and I got 25 by 6, and it would be something like 13 something,
And
maybe.
and actually you did it right, but you missed one part of the question actually, Vishal. I was saying, tell me the length of the arc. This is not the area, this is the perimeter I'm talking about.
Oh.
Yep. So length of the arc. So we want, you started the right way, but you probably thought that okay, this is 60 and these two are same. So this, you imagine this is an equilateral triangle. That's how you said 60, 60, 60. This is 60, 60, 60. No doubt about it. This is equilateral triangle. But then I'm not talking about the straight line length. I'm talking about this arc's length. So here in this scenario, yeah.
That would be 25 divided by 6. That's what I got. 25 pi divided by 6.
25,
I got.
no, it will be 2 pi r. 2 times pi times r is 5. So 10 pi by 6. Yeah, so I think you're thinking the right direction. I'm just trying to put the last nail in the coffin, okay? So this is the circle. Now, how you have to look at it? You know that perimeter, that's why I was stressing on the properties a lot, right? When you say perimeter, when you say, you're talking about this length from here to here. So if somebody has to find out this part, this will be some portion of the perimeter. If I'm talking about the arc, this will be some part of the perimeter. How much that will figure out? If I talk about the area, meaning slice of the pizza, the sector, that is when you will look at the area and some part of the area. How much? That is what you will figure out.
I thought it was the arc sector area. I accidentally put pi r squared instead of pi r2.
Right. No, so see, Vishal, I mean, one thing is for sure. I know this one was very familiar to you, and you were thinking the right direction. You probably picked up, you probably heard the question different, or you interpreted it differently. But yeah, your solution approach was perfectly fine. There was nothing wrong with that. Yeah. So that's where the read of my plan is very important. So no damage done in the class, but when you're in the examination hall, that is where you would want to put little more energy to read the question again and again, to make sure that there's nothing ambiguous with respect to how you have understood the question. Because if you have understood the question right, then doing it is not a big deal for you all, right? Because we know the formula, we learn how to prove the formula and then how to apply the formula. Only magic lies in this part. And that's why I keep on emphasizing on read, and read. Okay? And you have to make that as a practice. Not only you as in everybody, each one of you. Whenever you have a question, make sure that you are putting that extra effort to read the question a couple of times, at least 2 times, till you, before you start solving it. Because this will be the reading the question makes the question easy. That's what I very strongly believe in. So let's go back to this one. So now what the approach would be? So I said, if I've been asked to find out the arc, I will look at the perimeter and find out what portion of the perimeter it is. If I've been asked to find out the sector area, then I look at the area and then see what portion of the area it is. Now everybody knows that a circle makes 360 degrees from beginning to end. This is 360 degrees. Now if I'm talking about the chord which is making, let's say, 60 degrees. So if it was 360 degrees, that would have been the full perimeter. Here, since we're trying to find out the arc, if this was full circle, we would have got the entire 2 pi r, the entire perimeter. We are talking about one portion of it. How much is that portion? This is 360 degrees would have been the complete 2 pi r. If it was 1 degree, it would be 2 pi r divided by 360. Since we are talking about 60 degrees, it will be 2 pi r divided by 360 and multiplied by whatever is the value for 1. So for 1 degree it is this much, so for 60 degree it will be 60 into this. Yeah. And then you put the value of r, which was 5, so you put r equals to 5 and you do the magic. Yeah. So it becomes 2 pi r, 2 pi 10 into 60, 600. So it will be 5 by 3 pi, and pi we know that is 22 by 7. So you multiply this, it becomes 110 divided by 21, and whatever it comes down to. Yes, this many centimeters. We are talking about the arc. Now, is this part clear so far? And again look at, see, none of the concepts in math are difficult if understood correctly. Now, this is the circle. I am saying find out the length of the arc. As soon as you look at this and apply the Tran formula, find out the length of the arc. You are reading the question again. Find out the length of the arc, and then you start putting your analysis brain. Oh, find out the length of the arc. That means if I am talking about the entire thing, I am talking about the entire perimeter. I have been asked to find out the length of the arc, which is part of it. So it's some part of the perimeter. Okay. And how do I know what is the perimeter, formula for perimeter? Yes, I know this is 2 pi r. So this will be some part of the 2 pi r. How much? If this was the entire circle, this would have been 360. We are talking about only one portion of it, which is 60. Oh, so it is probably 1/6 of this one. And then you call Mikey. Just do it. Right? So look at the sequence of events. If you read the question enough, and if you put your thinking brain together, collect your thoughts, and then imagine or visualize, make your blueprint, say, okay, how I'm going to go about it. Once you have that all done, this is the easiest part of the job. And the chances of you going wrong is going to be less. So bring that to practice, and you will see the merit in what I'm talking about. Now, let me flip the question. Now, I have a circle. I have a point. I have 2 points, which is making 80 degrees. Find out the length of the arc. Or let me flip it. Since I said I'll flip the question, I'm saying the 2 points in the chord makes 1/4 of the perimeter.
What makes 1/4?
1/4, the 2 points on the perimeter, the arc of the perimeter makes 1/4 of the perimeter. Find out the angle, find out the center angle. So, again repeating, in a circle, I have taken 2 points of the perimeter such that it is 1/4 of the perimeter. Find out the center angle. Is that question heard, understood well? Everyone?
Is it 90 degrees?
Yep. No, the answer is correct, but I will still not spare you. I would still want to hear your thought process. How did you think about it? Again, that's more important, right? When you solve it, it's very important to understand what was your thought.
Because it's like, because 1/4 of like, I don't know how to explain it, because like it kind of forms like, if you drew like a line connecting those 2 points, it
let's see what Vishal and Vivun want to say.
Wait, 1/4 of 360 is 90. So,
Yeah,
um,
that's one approach. Yeah, yeah, Vishal.
Never mind. I was thinking of that the same way, like 1/4 of 360.
Right. So again, see, the trust me, nobody is more intelligent than you guys. Okay. When the examiner gives you guys a question, you can assume that he or she is not smarter than you guys for sure. They are just trying to see what your approach would be. Now they're not saying 1/4 of the perimeter. See, 1/4 of the perimeter. What was my intention here? I was saying that perimeter is the full perimeter. My arc is just taking 1/4 of it. And see, it will make full circle if I am going for the entire 360 degrees. It will make half circle if I am going for 180 degrees. Right? It will make 1/4 of circle if I am going for 90 degrees. Meaning 360 divided by 4. That is what will make 1/4. 360 degree by 2. That is what will make half of the perimeter. 360 divided by 3. That is what will make 1/3 of the perimeter. Correct? So you have to always relate it that way. I mean, as long as you remember that the total circle, I mean, the circle makes a total angle of 360 degree, and what is the portion that has been talked about, then you can just relate to it. Now, yep, yeah, Vishal.
I also looked at it in a different way.
Mm-hmm.
So I know that the whole circle is equivalent to 2 pi.
Mm-hmm.
So and if I divide 2 pi r or 2 pi divided by 4, that would be 1/2 pi. So that's basically 90 degrees.
Yep.
Because
Yeah.
180 degrees pi, so half of it is 90.
Correct. Yeah. Yeah. I mean, so the same thing. I mean, you can interpret the same question or solve that question 3 different ways, 4 different ways, depending on how you are approaching it. So that's why you would have seen that I get very excited to ask you guys to understand the approach, because that is what matters the most. If your approach is right, you are ready to solve hundreds of problems. If your approach is not right, you are limited by only the number of problems that you have solved. Right? Yeah. So Tanu, Vasundhara, Sanvi, everybody with me? Lakshita?
Yeah.
Everybody able to follow what we are doing? Okay. Now let's learn one theorem or one interesting stuff about a circle. Okay. If I have a circle like this and I pick 2 points, A and B. This is a chord, this is my arc, and this is the center angle. Let's say my center is O. Okay. Now let me tell you guys a magic trick, mathematical magic. You pick any point here or here or here or here or here or here, anywhere, but make sure this is on one side. If you join this point, this angle will be half of this angle. This angle will also be half of this angle. This angle will also be half of this angle. This angle will also be half of this angle. Tell me who all knew this before. This is one of the circle theorems. Nobody?
I never heard of it, but I saw a picture similar to that in the book.
Okay.
In a book.
Now, but it's not that okay, your teacher has told something and you have to believe it, right? You don't really have to. Your teacher could be wrong. Your teacher is getting older. He will soon have short-term memory loss problem also. Right? Then you're not supposed to trust me blindly. If I say that okay, if I pick a chord, it makes a center angle. This center angle is double of any angle. Meaning if I randomly pick any point here also, if I join this point and join this point, this angle is also half of this. But why? How? Why to trust the teacher? Let's let the teacher honor what he said by proving this. And now you will see how this is true. This is my circle. You guys are interested in knowing this, right? Yeah, want to know that, right? That magic trick? Okay. So this is my center angle. What I'm saying is, let's pick any point. I pick this point and I join these. So what I'm trying to say or convince you guys is, this angle is half of this angle. Let's look at it. Let me draw a better picture because this will challenge my drawing skills and it will be difficult to visualize. Let's pick any point here, okay? Join this, okay? Now I'm saying this angle is half of this angle. Let's say this is C. So what I'm saying is angle AOB is 2 times this angle ACB. That is what we are trying to prove, right? Because I have told you guys, I have forced you guys to believe this one. Let's try proving it. What I will do is, I will just join these 2 points, okay, and extend it here. Now look at this triangle and this triangle. Now look at now let's look at this triangle first. Let's look at triangle ACO, meaning I'm talking about this triangle right now, okay, and let's say this line extends further and comes to D. Now in this triangle, do you see this side and this side are same? Both are radius, right? If the sides are same, then the angles will be same, right? In the isosceles triangle, the two angles are same, right? So this angle and this angle are same. Now look at, so now when I look at this triangle, I can say angle AOC, meaning this angle, plus this angle, meaning angle